Today I'm going to show you something that's never been done before. I'm going to take an Angular 5 progressive web app, make it 100% optimized for search engine crawlers like Googlebot and Bingbot, make all of your routes readable by social media link bots, make it fully compatible with AngularFire 2 or any other asynchronous data source, and we're going to do this all without ever using Angular Universal. We're going to do this with a brand new library from the Google Chrome team called Rendertron. If you're not familiar with Headless Chrome or Rendertron, I recommend watching Sam Lee's talk at Polymer Summit 2017. It is truly mind-blowing if you've ever struggled with client-side JavaScript frameworks and search engine optimization. What I'm going to show you today is how to use this tool with Angular 5 and Firebase Cloud Functions, and you're going to be very surprised at how easy this is to implement with an existing Angular app. I have a full working demo deployed to Firebase hosting that you can test and validate, and I'm also going to be sharing all of the source code on angularfirebase.com. If you're new here, make sure to subscribe, and if you want to keep this content free and frequent, consider becoming a pro supporter. Let's take a closer look at how this system is going to work. We have just a regular Angular progressive web app deployed to Firebase hosting. Then we have our Rendertron app on the right. Rendertron is just a Chrome browser that can run on the server, meaning it can render your site just like a normal user would, and then it can return that data back to a bot that wants to read the meta tags or any asynchronous data that was loaded into the page. From there, we're going to set up a cloud function to serve as middleware that will determine if a user is a bot or an actual human that should receive the normal Angular app. Let's say someone shares a link and the Facebook bot wants to crawl your site to show a preview of that link. The cloud function will route the request to Rendertron first, then respond to the Facebook bot with a fully rendered page. This means you can create meta tags dynamically or load data asynchronously, and it can still be read by any kind of bot. If a regular human comes to visit the site, it's going to skip Rendertron and just serve the Angular app directly. If this user decides to share a link from your app in social media, it's going to show any meta tags associated with that page. The Chrome team has an instance of Rendertron deployed, which you can use now for your own app. However, it's not recommended for production use. I'm going to show you how to clone the project and deploy it to App Engine if you do want to use this in production. It's a Dockerized project, so you can actually deploy it to any backend that you want. But for testing, you can just use the instance that Google has deployed. It exposes a very simple API. You simply pass it the URL that you want to read, and it will render and serialize that URL. It listens to the initial page load, as well as any asynchronous events and network calls to load additional data into the page. It gives you up to 10 seconds to render the page, but it will send the response as soon as the page is finished rendering. So now that we know how Rendertron works, let's go ahead and build an Angular app that can actually put this to use. The first thing I'm going to do is generate a new app and make sure to include the routing module. Then I'm going to go into the index.html file and add some meta tags for Twitter and Open Graph. If you're not familiar with meta tags, they just tell link bots how to display your page. To show a Twitter card, we just give it a title, description, and image. If someone links this page, Twitter will know exactly which image to display and the description to show in the Twitter platform itself. The meta tags I'm showing you here are designed to be a default fallback if we can't dynamically generate them. They should convey general information about the homepage of your app. Now we want these meta tags to change for each individual component that's loaded by the router. So we're going to do that by generating an SEO service. The first thing I'm doing is importing the meta service from Angular, which just is able to set meta tags dynamically in the head of the document. And then we'll inject that in the constructor. And I'm setting up a configuration object here. You're probably going to want to customize this for your own app, but it just takes named arguments that you can override with your own configuration object. The whole point of this method is to avoid repeating these meta tags over and over again for each individual component. We can set them from the service by calling meta update tag along with the name and the content that we want to show. The structure of these tags will mirror the meta tags we set in index.html and then update them when a new component is rendered. We can set the values using that configuration object, which keeps our code dry so we're not repeating update tag in each individual component. I'm going through this quickly because each update tag method is exactly the same. Now let's put this service to use in a component. So I'm generating a new component called About Page. I also created a few other components and we'll load all of these in the router. We will first import each component, then we'll add them to the routes array. Each route will have a path, that's where you navigate to in the browser, and then the component that you'll render imperatively using that route. Now we need to set up a few links so users can actually navigate to these routes. We can do that using the app component, and you should see the router outlet at the bottom, and then we'll just do a router link for each of our paths. Now for each of these components, we can generate the meta tags dynamically. So all we have to do is go into the component TypeScript and import the SEO service. And then during ng on init, we'll call that generate tags method with the configuration options that we want to set. So for the homepage, we'll set the title, and then we'll say the description is my SEO friendly homepage in Angular 5, and give it an image as well. Then we can switch over to the about page and do the exact same thing. So that'll set the meta tags dynamically for any component that's loaded by the router. You can verify this is working by opening your app and then going into the head of the document, and you should see the meta tags change like this each time you navigate to a new route. That's pretty cool, but I want to take this a step further and generate the meta tags dynamically with data loaded from the Firebase database. I have another component generated called Firebase Demo that's exactly the same as all the others, but in this one, we're going to import the Firebase database. For this part, you need a Firebase account as well as Angular Fire 2 installed. You can follow the official instructions on the main repo. I'm going to import the Firebase database, and you could also use Firestore here as well if you wanted to. Then we'll need an RxJS observable as well as the take operator. First, I'm setting up a reference to the Angular Fire object. Then we'll retrieve that data as an observable. Then we'll inject our SEO service as well as the Angular Fire database in the constructor. To make the reference, we just call dbObject, and I have this data saved on the demo node, and then we get the data by calling value changes. Let's quickly jump into Firebase and see what this data looks like. For this demo, it looks exactly like the data we had hard-coded in the components earlier, but we're going to load it over the network via Firebase. To set the meta tags, we're going to call take1 on the observable, and then subscribe to it, and with the emitted value, we're going to use our SEO service to set the meta tags. The data we get back from the subscription will be that data we just looked at in Firebase, so we can set the title, description, and image meta tags. So that's all we need from Angular. Now it's up to Rendertron and Firebase Cloud Functions to make this SEO friendly. First, I'm going to show you how to deploy your own instance of Rendertron so you can use this in production. Google may offer this as a service in the future, and I hope that they do, but for now we have to deploy our own instance of Rendertron. For testing, this part is completely optional, so if you want to skip this step, you can go straight to the Firebase Cloud function. For this demo, I'm just going to clone Rendertron directly into my Angular project, but you'd probably want to have it as a standalone project separate from Angular. I'd also like to point out that you need to have Docker installed. The system requirements vary, so I'm not able to show you that step by step here. The next step is to cd into that directory, then run the docker build command. It will take a few minutes to build the container, but once it's finished, you should be able to run docker run and serve it locally on your system. If you navigate to port 8080, you should see the Rendertron app running there. This is great if you want to customize Rendertron source code for your specific needs. If you already have a project with Firebase, you can deploy the container to App Engine with a single command. You'll first want to go into the app YAML file and set the number of CPU cores and memory that you want to use. If you have the Google Cloud Platform command line tools installed, you can simply call gcloud app deploy with your corresponding Firebase project. That's going to take another few minutes, but it'll give you back a URL with your own custom production-ready version of Rendertron. Now we're ready to create the Cloud Function middleware that will determine if the user is a bot or an actual human. You'll need both Firebase hosting and Firebase functions initialized in your project. Then we need to configure hosting to use the Firebase Cloud Function for any URL other than the root URL. So we do that by adding it to the rewrite section, and the function is going to be called app. Before we get into the function, I'd like to point out that Rendertron has an existing Firebase Cloud Function designed to work with Polymer. It's not compatible with Angular, but it might be worth checking out. So getting back to our app, we're going to cd in the functions directory. Then we're going to install Express.js, which will give us some syntactic sugar for routing, and also a library called node-fetch. Then we're going to go into the index.js file and import these required libraries. We're also going to import URL from Node and then set our Express app as a variable. Then I'm going to set our URL endpoints directly in the function itself, but you could also set these as environment variables. So the app URL is going to be the URL that we deploy our Angular app to in Firebase hosting. And then the render URL is the Rendertron endpoint. So you can use this Rendertron endpoint exactly as it appears here. But if you deployed your own, then you would use your own render URL. So we'll export a function called app, and that's going to give us access to a request and response object. And we're going to use the wildcard character to catch all routes. The first thing I'm going to do is write a couple of helper functions to make this a little bit easier. So first we need to generate the URL from the request. So it won't be in the correct format unless we use the node URL library. So we'll get the protocol, the main app URL, then path name is the actual route the user is trying to get to. To detect search engine crawlers and social media bots, we're going to create a big list of known bot user agents. So probably the most famous is Googlebot, but Googlebot's good at executing JavaScript, so you may not even want to include it here. Then we'll also set up our social media bots that would be like TwitterBot, Facebook, LinkedIn, Slack, and many others. This list isn't comprehensive. You can definitely add additional values here to detect other bots. The way we actually detect a bot is from its user agent header in the request. So we're going to take that header and convert it to lowercase. And then we're going to loop over this list of bots. If we detect the substring in the header, then we're going to say the bot was detected. We can console log it for debugging, and then we'll return true from the function. Otherwise, we're just going to return false. When the cloud function is invoked, the very first thing we're going to do is run this detect bot helper with the request header. If it returns true, we'll know that we need to send this request to Rendertron first. So if that's the case, then we're going to format the URL properly to send it to our Rendertron endpoint. We can do that with the generate URL function we created earlier. And then we'll call fetch to fetch the actual URL. So we call the render URL / bot URL, and that returns a promise. Then we'll get the text from that promise. That will give us a response body that we can send back to the actual crawler bot, but we're going to define some caching on it. So we can set the cache control header. Then we'll set the vary header, which signals which part of the request was important in determining our response. In this case, the user agent header is what determines how we build this response. The last thing we'll do is convert the body to a string, and then we can send that as our response from the cloud function. That will be a fully rendered and serialized web page that can be used by the actual crawler bot. If we don't detect a bot, then we just want to display the main Angular app. We can do that by simply fetching the root URL that's deployed to Firebase. We can handle the response in the same exact way. We'll just turn the body into a string and then send that as a response from the cloud function. You could probably optimize this to be faster, but it's only going to fire when you don't go to the root URL. Because of Firebase hosting priorities, it will use the index.html file when you navigate to the root URL on your project. I discussed this in more detail in the main article, but for now we're just going to go ahead and deploy the function. So run Firebase deploy only functions. Then you'll also need to create a production build for your Angular app, so run ng build production, then run Firebase deploy only hosting. Just like magic, your progressive web app is now optimized for search engines and can be used by link bots, and you didn't have to break your Angular app in the process. All of this is very cutting edge, so I recommend you check out my working demo and reach out on Slack if you have any questions. For each page in the demo, there's a URL, and if you paste that into any social media outlet, you should get a link preview, or if you fetch it as a bot, you should see the fully rendered HTML. That's it for Angular SEO with Rendertron. If this video helped you, please like and subscribe. And if you want advanced exclusive content related to these topics, consider becoming a pro subscriber at angularfirebase.com. You'll get a free copy of my book, as well as one-on-one project consulting. Thanks for watching, and I'll see you soon.